Please welcome on stage Martin Fitzel and Wilhelm Behnke.
Hello. Am I audible? Do you hear me? Yeah, nice. Welcome to our talk about atomic fusion and Zeitgeist monocle. Don't be afraid of the fancy terms. This is all stuff we came up with, and by the end of the talk you will have an idea what this is. I am Wilhelm. I am NEOS developer at Zeitgeist, which is also organizing this event here. And I'm also a NEOS core team member. But I'd like you to be aware of that this talk is not on behalf of the NEOS core team. This is merely experience we collected with Zeitgeist while using NEOS as a product.
Thank you. My name is Martin Fitzel. I'm also a developer at Zeitgeist. My focus is solely on back-end development. And I'm also a member of the NEOS core team. But it's always hard to remember names. We want to give you an image. We are Stedler and Waldorf of fusion development. And what's the thing Stedler and Waldorf can do best? They rant. And we want to rant. And we want to rant about fluid partials and logic in templates. So, yeah. And Dimitri did that already, but it is important. So why is that bad? I want to show you the evolution of a partial. In the beginning, a front-end developer handed over a simple image tag to the backend. It's very beautiful, just a tag with some attributes. So what can go wrong? Well, first thing the backend does, it switches the image tag through a fimage view helper. By doing so, the partial gets a dependency to the NEOS node module, or node domain model, and all the attributes are replaced by curly braces. So maybe the front-end developer will still recognize it, but not all of them will do. But the worst thing is that's not the end of the story. Let's add another requirement to the partial. We want a link to the image. And this link shall only be rendered if it is set, and in the backend, you obviously don't want to render the link because you have to select the image without losing the site you are on. So this is what you end up with, a partial with tons of conditions, and the front-end development will never understand what's going on. They cannot change it anymore. It's simply impossible. So, and what is even worse is that this is not an artificial example. Who knows such partials?
Oh, yeah.
Yeah. What?
Oh, yeah.
Yeah, but whatever you want to add, it will explode. It does not work. So, what are the specific challenges we are facing in large projects? Partials don't scale. They explode whenever you add requirements, and mostly you end up with just duplicated code. So, who many of you has multiple teaser partials? I think you know the effect. Partials mix front-end with back-end concerns like visual representation, data structure, and editing experience. And once a partial is modified by the backend, the frontend cannot change it anymore. And this makes the development a one-way trip. So there is only communication in one way, from the frontend to the backend. And this is the real problematic part. Because if we do bigger projects, we have to iterate, we have to communicate. So we have to collaborate better.
So how do we solve the collaboration problem? If you think about a classical waterfall approach to your view layer, it will begin somewhere in the graphics department. They will come up with a layout that showcases the entire big picture of a page. basically. They hand it over to the front-end department. They will make a prototype in HTML, put in JavaScript and CSS. This will be handed over to the back-end department for splitting it up and integrating it with content data. The problem with this process, though, is at each step, information gets lost. And when it comes to the integration part, it is very likely that the original intent behind the design is somewhat obscure and not really recognized anymore. So it might be that we've been through this process, that your graphics guys and front-end guys stick their heads together and come up with a plan. And this plan is, we are going to build a huge, beautiful style guide, and we are going to make the back-end department pay for it. Well, of course, this solves this information problem, because a style guide is basically showcasing not only the big picture, but all the content elements, all the design elements, fonts and colors in the way they are supposed to be used, and document all the things that are intended with this. When it gets handed over to the backend, if they stick to it, it will still be applied. But later in the process, when some conceptual change comes in, and those come in quickly, even by bug reports or something like that, if you are serious about this approach, you need to go back to the style guide, change the things, and reiterate over the integration. So as soon as the project is under pressure, you will most likely abandon this practice, and the style guide becomes less and less relevant to the project until it is practically useless. So your style guide might be great, but it is doomed. There is a concept called living style guides to solve this. Style guides that are generated from your living code base, so they grow as your code base grows, and they have a better chance to stay up to date. Most of them try to get the single source of truth from your CSS code base, because it is very unlikely to change during integration. You still have to write some example HTML code in there, and you still have to take care that it's up to date, but it is a much more powerful concept. So we looked at this, and we said, we want this for Neos, but we want a supercharged version of it. We want it to be integrated with your workflow. We don't want extra data. We don't want it to be copy-paste and things like that. So what do we have to do to get this? It starts with a core desire that most front-end guys have, but never express like this. They don't want state in the view. It needs to be separated out. What this means exactly, we are getting to now. So take just a simple content element. This is something we all have integrated, I guess. And I see some of you are already getting into how this works. Conceptually, we need a node type for this. We probably have an image property, headline property, text property, button, link, all this kind of stuff. We take this data and throw it into a template that will basically resemble this structure entirely. And then we are done. So here's our template. Well, we cannot really reuse now this button, for instance, except for we just add a link somewhere and add the same class or something like this. So let's rethink this a little and break it down to all these semantic elements here. Let's make smaller modules out of it. An image module, headline module, text module, and button module. All of them separated out. And now we have a couple of small single-purpose modules that can be composed to a bigger structure as the teaser here. And now we can basically reuse those components and stick them together to new structures that still speak the same design language as the teaser before. So the concept that I'm talking about here is, of course, components. And components have become a very dominant idea in the front-end world over the past few years. All of you have heard about React and all the derivatives, Preact and Inferno. You have heard about the component concepts in Angular, Ember, Vue.js, and the upcoming web standard of web components. So components are becoming a native concept in the web. There's no way to get around it. But it's also kind of buzzwordy. It's not very clear what components actually are, and they can mean different things in different contexts. So I want to give you an idea what we mean when we say component. Components are solely determined by their attributes. This is the first principle. And attributes is an arbitrary term. You can replace it with props or options, parameters, whatever you want. The important thing is one set of input must always lead to the same set of output. It must be side effect free. Components should be single purpose. You all have seen the Franken partial from the beginning. Something like that should not be done with components. They should serve one purpose, they should do one thing, and this one thing very good. And they should be reliable. They should ideally also encapsulate everything that is needed to move them around, put them in new contexts, in new projects even, and they still behave as expected. So this is the general idea. We have taken these principles and tried to move them into the Neos Fusion world. And this is what we came up with. It is called Atomic Fusion. And now you can see that we are really glad that the language is called Fusion now. We had the atomic part already in place, and now it really makes sense. And Atomic Fusion is both a mindset, architectural principle, and a usable package. And this is how a component in Fusion looks like. You just have a prototype that inherits from Atomic Fusion component. You define a component API. These are your attributes, basically. In this case, text in URI. And you define a renderer that takes care of the actual rendering process. What this thing does is it takes the component data, the component API up here, and puts it into a closed context called props. The renderer has access to this props context, and so you can use the data from above. Important is that the outside world does only care about what's in here. So this component is completely agnostic about what kind of data is coming in, so what the data source is. It could be a node, it could be some API data, it completely doesn't matter. So we have kind of these principles in place now. You can take, if you have some of these smaller components, smaller structures in place, you can take them and compose them to bigger structures. And in our experience, it's really nice because if you go up the abstraction levels, it becomes less and less code. So you actually have smaller components like a button that are kind of bloaty, but your page is 3 lines then or something like this. It's really great. So Atomic Fusion, that's all there is to this idea. Atomic Fusion shall not be confused with atomic design. Atomic design is more of a design principle, of course. You can use Atomic Fusion to implement atomic design, which is pretty, most front-end people are pretty familiar with atomic design, and we do actually use it in some projects, but you are not bound to do that. Atomic Fusion can be used independently. It's also not to be confused with nuclear fusion, because atomic fusion can be used today. Nuclear fusion, probably in some obscure utopian future. So it is available on GitHub. You can install it via Packagist. It is there, you can just use it. It's very small, and it has a very stable API. It's very unlikely to change, so just try it out. And we use it successfully in production in basically all of our projects today. So, but now I'm kind of too deep into this component thing. We wanted to have a style guide in the beginning. Are we actually any closer to this now?
I don't know. Actually, we were able to build a style guide on top of that, and that is a thing we are calling Zeitgeist Monocle. It's also a package, and we need two more things to add to this component to be able to actually render a style guide. We need some metadata, and we have to provide the dummy data that is used for the rendering. So how do we do that? What we want is we want to be able to versionize that, and we want to be able to change it with our code base. The solution we came up with is annotations. Fusion has this nice concept of annotations that you know from add concept, add if, add process, and it turns out that this is extensible. All annotations are passed by the parser, but they are simply not evaluated. But we can use them, we can read them, and we can use them to create the style guide. What we are doing here is we provide in an add style guide annotation some metadata like a path, where this component is localized in the component hierarchy, a title and a description for obvious reasons, and some preview data, which is used when the component is rendered inside the style guide. So, okay, now we have all the pieces. What do we get for that? Well, first of all, you have to log into Neos because it's a Neos style guide. And in the backend, you select the backend module, which is called Monocle. It's protected by own policies, so you can adjust who can access that. Currently, all editors can. And to actually show it, you have to open it in a new window because we need all the screen space we can get. The application itself is quite simple. It consists of a navigation bar on top and the preview section below that renders the single components. So how do we structure that? To actually structure the component hierarchy in this project, we used the principle of atomic design, which makes sense, but there is no dependency on that. And we create atoms, molecules. And first, I want to show some molecules. First one here is an intro block, which should be consistent across multiple pages, so we created a molecule from that. But of course, there are molecules for navigation. This one will be inside a dropdown. And of course, teasers. Projects are mostly about teasers. In this case, you see that there are components which contain multiple teasers and also components that are a single teaser. The components with multiple teasers consists of multiple items of the single teaser component. It's, in the end, quite simple. So, yeah, simple. So on top of the molecules, we have some organisms. In this case, this is the header and the footer of the site. The naming of molecules and organisms is not very good, but it's things that are composed of other things. And the uppermost element is a page which contains everything and some dummy content, which is quite short in here. But that's the thing you get, how you navigate the components, and you can preview them. Let's look at a single component. This one is a teaser. And of course, we have a preview iframe that contains only the component and the CSS, so there is no side effect with the style guide around. You can show the code. There you see the rendered HTML. That is quite simple, but you can also show the Fusion code that was used to render this component. And actually, you don't see the Fusion code that you wrote. You see the Fusion code that got parsed. So if anyone overwrote your component, you will see it there. And you can also see the Fusion AST if you're into details. So there is a reload button, and The next one is more interesting. It's a full screen view, but think about that. This is a full screen view that is rendered without access to the database of your component. So this is an endpoint that makes total sense to integrate in any testing tools. You can use Phantom.js to take screenshots of that. You can validate the created HTML output, if that is of any value for you, but this is very interesting for testing. So the last thing I want to show you of Zeitgeist Monocle is the responsive preview. You find it on the top right corner, and you can configure the breakpoints that are relevant to your project. So we don't make assumptions here. Whatever you need, you can just select the breakpoints, and all preview iframes are scaled accordingly. So I think that's it. Do you like that? Do you want that? Let me conclude. It's on GitHub and on packages. We use it in production every day in all our new projects. And to make it clear, it cannot break your front end. It is only active in the back end. All the tricks it does to render your stuff are only active inside the style guide. So the front end is not affected by that. It does not need a database. It can use in CI service, and your front-end developers, if they use it as a tool, they don't need a database. They only need PHP. So to use Fusion to create a style guide does not require a complete Neos installation. You have to use PHP and Composer, and that's all. Actually, another interesting side effect of rendering without accessing the database is that this really makes sure that your components are side effect free. So inside a component that is rendered in Monocle, you cannot access the content repository because you should not. These are presentational components which only serve the purpose of presentation, of visual representation, and not of data acquisition. So this brings us to the next thing, data acquisition, and this is for Wilhelm.
Well, you probably are now going to say, this is all nice, but I'm supposed to render content. I don't want to be the backend guy who has to pay for the style guide. So how do we do that, actually? This is a process we call mapping in Atomic Fusion. So you have the presentational components, and you use them in a different process to just throw in the data, basically. So this is a presentational component, molecule teaser, and we put in the node property layout into the layout prop. Here, the title property of the node into the title prop. And even if you want to have editable content, we can just wrap it like this and pass it as a prop as well. So it's very easy to do that. And everything is cleaned up nicely, because if now some conceptual change occurs, and the front-end guy needs to adjust the presentational component, as long as this API doesn't change, you have to do no integration at all. This is another example. This is how we used to render pages. We just take the Neos page prototype, the standard prototype, extend it, and overwrite the body with a big template component. In this case, we throw in navigation items in there that we construct with this Fusion raw collection. So there we actually build up an array that can be interpreted on the component side. So this is very flexible. Here we throw in just the main content collection, and everything goes as expected. So this is really a clear separation of concerns, and nothing breaks if we just have to do some visual changes.
So let's conclude. What were the challenges we identified in the beginning? Partials don't scale, but presentational components do. They do one thing and they do it good. Context boundaries between presentation and data acquisition are missing, but we can implement it in Atomic Fusion by separating presentational components from mapping. In Fusion, we can still cross all boundaries we need. So if you have to deeply interfere with a component and to adjust the renderer, you still can do this. There's nothing the Atomic Fusion component does to prevent you from that, but you will probably recognize that you are doing something that will likely break in future if you're changing a renderer of a component you are using. So we don't forbid it, but we make it clear to people who are using it that they are doing things that are maybe not that smart.
Put it in the shame fusion, though.
Yeah, put it in shame fusion. That's a good idea. And by doing so, by separating presentation from data acquisition, we can allow front-end and back-end to collaborate and to progress independently. So, yeah, and so in the end, what we basically are proposing here is that we use the attributes of Atomic Fusion components as the interface between front-end and back-end development. For us, it turned out really nicely. It's in the beginning a bit strange for front-end developers, but they quite
actually
soon realize that they get something for it.
Yeah.
So that's it. That's two very simple things. And in fact, it was not that simple to get to the point. It is basically the essence of 2 years of experience with Neos projects and trying to create a style guide and creating components, failing, trying again, until we came up with that. So, and now we are quite confident that we have found a simple solution that is a solid foundation, but we introduced us as we are always complaining and we are not satisfied yet. So this was a thing that you can use today, but there is still some experimental content ahead. If you write Fusion components like we proposed, it sometimes is looking like that. And of course, I will not argue, the definition of the renderer is quite verbose in this case. And at first I would say you should make your components smaller, but that's in reality not always possible. And of course it's true, it's still more verbose than HTML. The good thing is we are not the first ones to run into such issues. The JavaScript world also experiments with components for some time, and they came up with a solution, and that is called JSX. And what JSX is, it is a domain-specific language that is implemented in JavaScript, and that is internally converted back to JavaScript. It is just another notation which is more effective for a specific purpose. So we transferred that idea into the Fusion world. And what we got is a thing we call AFX. And I can switch back and forth. It's the same component. It's just another notation. And the thing AFX does is that it takes your Fusion code, it detects the AFX parts, and it expands them to pure Fusion code before the whole stuff is handled by the parser. So internally, this will be the same as the code before, which is quite important. This is not a template. This is Fusion code. It is cached as the Fusion code before, and it has also this unplanned extensibility feature. So if I place a key in here, the key headline, I can override in the renderer via the key headline every property of this tag object. So it is still extensible even in unplanned fashion, and that is a thing that in many projects covers your ass whenever your customer comes with late requirements. So, of course, let me explain a bit how this internally works. There are mainly two rules inside AFX. Tags, which have no namespace, are just converted to Neos Fusion tag objects. And everything that has a namespace is interpreted as being a Fusion prototype. So that's basically all rules that we had to apply. We had to do some special handling for add if, or add process, if you like, or even the add key to make things addressable. But yeah, it's still quite a simple concept. I have to warn you, this is experimental. We did not release it yet, it's on GitHub, but we are still figuring out the details. Currently, it uses an aspect inside the Fusion parser to expand to Fusion code. This will likely change in the future. We are already working on creating an extension point for Fusion that will enable domain-specific languages to be integrated into Fusion. But this still has to be done. There is a pull request, but yeah, it's not in yet, it's not released. And also the details of the AFX language are still a bit to be decided. So the thing we are mostly figuring is the handling of white spaces. So if you have an opinion on that, we can discuss it on the social event. So yeah, so that's it. That's AFX.
So, what to take home from this? Don't use partials.
Really
They
don't.
They tend to become big Frankenstein constructs. We don't want that anymore. There are better ways to do it. You can use components. You can use our Atomic Fusion package to create and express those components. It is usable today. Just try it out. You can use Zeitgeist Monocle to develop those components in an isolated fashion with a nice responsive preview and all the testing abilities that come with it. So just to give you another visual idea of what we want you to do, stop squeezing your data into a steady template. Instead, use building blocks for it, small ones, connect them to bigger ones, build bigger structures, and you'll see the amazing result. That's it. Thank you, and good luck. Other questions? Yes.
The microphone is coming.
So why did you use AFX instead just instantiating a Neos Fusion template at that place? Because you can...
Because of unplanned extensibility. And I can use other components inside. So
You can
I can
with a
use the
template.
AFX language to compose components. If I would use a template, I would, you mean by using tsrender or frender? Not really.
Yeah, you could do... if you use a Neos Fusion template and you use that small snippet of HTML code and you would like to use another atom, a prototype, you have that as a renderer. So you just say, okay, now give me button equals
Then
atom dot
in that
blah,
case,
and
I
then
have-
you say button format raw in the template.
You can basically do that. It is not forbidden to use templates, actually, or template objects. The thing with AFX is that we actually want a Fusion AST available from that.
Okay.
So that we get all the benefits from an AST like this.
And to use a renderer inside a template, you have to map the prototype first to a property that you pass to the template. That's the thing is that you don't do with AFX. You just use the prototype name.
Okay, I get it.
So it's, yeah.
Any more questions? Over here or over there?
First of all, thank you very much. I think it's a great effort, especially having the AFX parser is quite astonishing. But I'm not totally sold on the idea because the complexity of the partial is just the same as of the Fusion part. It's just another syntax. I need to learn one syntax more, and most front-end developers are very easily able to learn Fluid, which cannot be said for Fusion. But it's just as a side note. What I'm more interested actually is how do you handle, especially in Monocle, complex JavaScript-heavy components, especially if they reload asynchronously the content. Do you just use some static and then map out every state that they can have, or is it just something that is beyond this approach?
Well, we have mocking mechanisms in place to have these asynchronous calls. So just some random promise that will give us maybe some dummy data. That's basically how we handle JavaScript. But JavaScript in and of itself is just initialized like on any other page. You can just address your component and do whatever initialization stuff you need.
And can you then give, if you write those components for Monocle, are they already in the folder, some folder structure that they can directly be transferred to the project, or do you have to?
They are in the project.
Okay.
This is a live Fusion code. It's just the presentational site that is rendered inside Monocle. The thing we are adding in the project separately is the mapping of the data acquisition. So whenever the style guide is changed, the whole project is changed. There is no difference in there. There's no copying things around or that.
Do you use this one folder per component approach that we have heard
Yes.
this morning? Okay.
Absolutely.
Yeah.
Hello. This looks quite similar to React. So I guess this is on purpose. And how big you think is the gap between Fusion and React? And is this a role model somehow for Fusion? Yes, for Atomic Fusion, sorry.
Well, as far as I know, Fusion is actually older than React. And the concepts in there are astonishingly similar. Yeah. So if you are familiar with React, you have absolutely no problem understanding what's going on in Fusion and the other way around. It's really astonishing. So there is, the only gap I see is one thing is rendered on the back end with a PHP background somehow and has completely different syntax, but the entire concept is quite similar. Yeah.
Thanks.
At the moment, you have to hack the core, right, to enable AFX. When is there any plans or a roadmap to get this into the core that we can use it without the hacks?
Hacking is not the correct term. We use unplanned extensibility. It is an aspect. So you don't.
It's a more diplomatic way.
You don't have to modify any files. You just install the AFX package, but it might break with a future update. In that case, you would have to adjust AFX.
We never said repeal and replace.
I think adding a feature to the parser is not that simple because there will be some discussions. For me, it works. I created PR this week on the code sprint, and I can use it, but I don't know when it will go in. think maybe 3.2, but I'm not sure about that. And in the meantime, we have a working solution. The thing that will likely change, or where I see more risk if you start your project with that today, is that the transformation between AFX and Fusion is not finally decided yet. So there are still some points to figure out what should be right and which will very likely be decided in the first project we are really doing, and very likely we'll still find things we want to change. So, but it's more like stuff, what should we do with white space? Should this be a string object, or should we ignore it, or something like that? So this is a level we are currently discussing. It's not the main thing, how it works and what it does. But we have no fixed date.
How much performance overhead does it cost to use AFX?
None, because internally it is Fusion. It's just the same.
To compile Fusion from AFX.
Yeah, but that does not matter because the past Fusion is cached. So this is not running every time you send a request to Neos. It's just done once, then the AST is created, and if you are previewing such a component with Monocle, you will not see AFX. You will see the Fusion code, because it is internally Fusion. Fusion is running.
So we are running out of time, a lot of interest, a lot of questions regarding this topic. Thank you very much. Please, I know you are getting lazy more and more after each talk, but do not forget to vote for the talks and use the possibility to ask the speakers here in all the launches. Thank you very much. And now we have the coffee break, and give a hand for them. Thank you.